Roughly 93 miles, about 150 kilometers off the coast of Washington state, hidden beneath the towering peaks of the Cascade Mountains, lies one of the most dangerous and least understood volcanic systems on Earth. At first glance, this region looks calm, even peaceful. Snow-capped mountains, dense forests, quiet valleys. But beneath that beauty is a geological reality that tells a very different story. This region is known as the Cascade Volcanic Arc, a critical segment of the infamous Pacific Ring of Fire, a massive horseshoe-shaped zone of tectonic instability that encircles the Pacific Ocean. This single region alone accounts for more than 75% of the planet's active volcanoes, and the Cascades sit right at its heart. For decades, many of these volcanoes were considered dormant, sleeping giants whose danger belonged to the distant past. That belief is now being shattered. Chapter 1. The 2025 Discovery that changed everything. In January 2025, a groundbreaking scientific discovery sent shockwaves through the global volcanology community. Researchers from Cornell University, publishing in the prestigious journal Nature Geoscience, revealed findings that fundamentally changed how scientists understand the Cascade volcanoes. Using seismic waves generated by distant earthquakes, essentially turning Earth itself into a natural X-ray machine, the research team, led by Dr. Wenjing Peng, created high-resolution images of what lies beneath 6 major Cascade volcanoes. What they found was deeply unsettling. Every single volcano examined contained massive, active magma reservoirs beneath the surface, not cooling, not solidifying, still molten, still fed by deeper sources. Even Crater Lake, which has not erupted in over 7,700 years, showed clear evidence of an active magma system below it. This discovery overturned a long-held assumption in volcanology that magma chambers beneath inactive volcanoes slowly dissipate over time. The reality, it turns out, is far more disturbing. These volcanoes never truly go cold. Instead, they remain quietly supplied with molten rock, slowly pressurizing, silently waiting. Not erupting doesn't mean harmless, it simply means patient. Chapter 2. Millions living on a volcanic corridor. The Cascade Range stretches for more than 680 miles, or 1,100 kilometers, from British Columbia in Canada, all the way down to Northern California. Along this chain sit 13 major volcanoes that together form one of North America's most dangerous geological systems. They include Mount Baker, Glacier Peak, Mount Rainier, Mount St. Helens, Mount Adams, Mount Hood, Mount Jefferson, the Three Sisters, Newberry Volcano, Crater Lake, Mount Shasta, Lassen Peak, and Medicine Lake. More than 10 million people live within this volcanic corridor. Many of them have no idea that beneath their homes, cities, highways, and power lines lies a living, breathing, magmatic system, one that is still active today. All of these volcanoes were created by the same relentless process, the subduction of the Juan de Fuca plate beneath the North American plate. As the oceanic plate sinks into the mantle, it melts, generating magma that rises toward the surface. This process has been happening for millions of years, and it has not stopped. According to the United States Geological Survey, 8 of the Cascade volcanoes are classified as high or very high threat, placing them among the most dangerous volcanic systems in the entire country. What makes the 2025 discovery even more alarming is something scientists did not expect. The presence of large magma reservoirs has no direct relationship to how often a volcano erupts. Professor Jeffrey Abers, a co-author of the study, explained that scientists once assumed that more magma meant a higher chance of imminent eruption. That assumption is now proven wrong. Instead, magma appears to be a permanent feature of these volcanoes, which means every single one of them must be monitored constantly, regardless of whether it last erupted decades or thousands of years ago. Chapter 3. Mount Rainier, the giant that never sleeps. Among all 13 Cascade volcanoes, there is one that keeps volcanologists awake at night: Mount Rainier. Rising 14,392 feet, 4,392 meters above sea level, Mount Rainier dominates the skyline of Seattle and Tacoma, 2 of the largest cities in the Pacific Northwest. Despite its serene appearance, Rainier is widely considered the 3rd most dangerous volcano in the United States, surpassed only by Kilauea in Hawaii and Mount St. Helens. But Rainier's danger isn't defined by lava flows or explosive ash clouds alone. Its true threat lies in ice. Mount Rainier is covered by 26 major glaciers, containing approximately 1.4 cubic miles, 6 cubic kilometers of ice and snow. That is 8 times more frozen material than was present on Nevado del Ruiz when it erupted in Colombia in 1985, an eruption that triggered devastating mud flows and killed over 23,000 people. Seattle and Tacoma themselves are built atop ancient volcanic mudflow deposits, some more than 30 meters, 98 feet thick, left behind by Rainier's past activity. These cities exist where destruction has already occurred before. Today, more than 80,000 people live in zones considered extremely high risk for lahars, fast-moving volcanic mudflows capable of erasing entire communities in minutes. These flows can exceed speeds of 40 miles per hour, 65 kilometers per hour, carrying rocks, trees, vehicles, and buildings like debris in a raging river of wet concrete. Volcanologist Jess Phoenix, speaking with CNN as an ambassador for the Union of Concerned Scientists, described Mount Rainier as the volcano that worries her the most, not because of one single factor, but because of a deadly combination: extreme height, massive glacial coverage, an active hydrothermal system, and millions of people living directly downstream. Chapter 4. The Silent Killer. Lahars Without Warning. Then came the event that pushed scientists into high alert. Between July 8th and late August 2025, Mount Rainier experienced the largest earthquake swarm ever recorded in its monitoring history. More than 1,350 precisely located earthquakes were detected, along with thousands more too small to measure accurately. The strongest reached a magnitude of 2.42, but the true concern wasn't strength. It was frequency. At the peak of the swarm, instruments recorded up to 40 earthquakes per hour, a rate never before observed at Rainier. The epicenters were concentrated roughly 2.8 miles, 4.5 kilometers below the summit, aligning precisely with the volcano's active hydrothermal system. Despite the intensity, scientists at the Cascades Volcano Observatory and the Pacific Northwest Seismic Network kept the alert level at normal. Their assessment: the swarm was driven by heated groundwater interacting with deep magma, not an immediate sign of eruption. Still, the message was clear: Mount Rainier is not dormant, it is alive. Seismologist Professor Seth Moran explained that when water penetrates deep into a volcano and encounters intense heat, pressure builds rapidly, fracturing rock and triggering earthquakes. While surface activity eventually declined, these hydrothermal processes may continue silently, out of reach of detection. And that's what makes Rainier truly terrifying. Its greatest danger does not require an eruption. The real nightmare is lahars without warning. Over thousands of years, acidic fluids from the volcano's hydrothermal system have weakened the upper slopes of Mount Rainier, turning solid volcanic rock into unstable, clay-like material. These weakened sections can collapse suddenly, triggering massive mudflows even on clear, quiet days. A 2022 scientific simulation modeled the worst-case scenario. A lahar, with a volume of 340 million cubic yards, equivalent to 104,000 Olympic swimming pools, could reach populated areas in as little as 1 hour, obliterating everything in its path. No lava, no explosion, no warning, just destruction. Mount Rainier stands today as a reminder that Earth's most dangerous forces are not always loud or dramatic. Sometimes they wait, silently, patiently. Share this video so more people understand the reality beneath their feet, and let us know in the comments which geological phenomenon you want us to explore next.